Hey Panthers! This video we are taking a look at rate of change, specifically with what we call direct variation. So again, make sure you have your notes in front of you, your pencil, your calculator. Remember to pause me if you need to. If you need to pause right now to get this your notes filled in, please do. But today's lesson is very similar to yesterday's lesson. If you remember yesterday, we talked about the constant of proportionality, which probably when you took the notes sounded a bit confusing. Basically, the constant of proportionality that we talked about yesterday is taking a look at data and seeing if the rates that are in the table or the rates that are in the graph or the rates that are given to you, you're checking to see if they are equivalent. And that is what constant of proportionality basically says. There is a constant of proportionality that exists if all the rates provided to you are equivalent to each other. And one way we checked to see if they were equivalent with each other was actually by finding the unit rates, or the rates for 1. And that's what we did yesterday with that k value. The k value is basically finding the rate for 1 to see if, because remember, if you find the rate for 1, then you can do comparisons. So today, again, we're looking at the same thing. There's just one little thing that we're going to add today, and that's called direct variation. So let's go ahead and fill in the notes, and then we'll go through some examples together. So some vocabulary that I would like you to be familiar with, and again, maybe making some flashcards of these vocab words would be a good way to prepare for the assessment. But linear relationships, if you think about the word linear, hopefully you see the root word line. But linear relationships are relationships that have straight line graphs. Now, for this particular lesson, we're not going to be graphing anything. However, we are going to be looking at some graphs. And I want you to just think about when you have graphs, you have your x-axis and your y-axis. And when you plot points, sometimes those points can be connected with a straight line. And when that happens, you would consider that those points or the data that you're plotting on your graph have a linear relationship. In other words, they form a straight line. For constant rate of change, we have that word constant again. Yesterday we talked about constant being kind of a repeated pattern, something that's happening over and over and over again. Remember yesterday when we found those k values? If you got the same k value over and over and over again, it insinuated that you had the constant of proportionality. So here we're talking about a constant rate of change, very much the same thing. This states that the rate of change between any two data points in a linear relationship is constant. Okay, so it's, again, another way of saying the same thing that we're saying over and over again. One thing in addition to this is that when you have a constant rate of change, yes, you have a linear relationship. And we have the word here slope, which we don't really talk a whole lot about in 7th grade, but is a big term for 8th grade. Slope is how steep or how flat your linear line is when you're graphing. So if you have a straight line, you have a constant slope or a constant rate of change. Then we have direct variation. Okay, direct variation is a type of linear equation. So certainly if you were to plot some information on a table, you would get a straight line. However, a direct variation, your graph, you want to remember this, the graph has to pass through the origin. Now when I say the origin of a graph, keep in mind you have your y-axis and your x-axis. The origin again is where the two axes meet, and this point is 0, 0 on your graph. Okay, so when I say origin, that's what I'm talking about. So direct variation is a linear line that goes through the origin, and of course it is proportional, which would have already been determined through the line, the straight line. And the last one, the constant of variation. Again, we just talked about this yesterday. Another way for saying constant of proportionality states that given a point from a direct variation, the constant of proportionality is that k value that we talked about yesterday. So if you take your y value and divide it by your x value, again, same thing as finding the unit rate, ends up being your k value. So, sure I've confused you again. Lots of vocabularies, words, a lot of big vocabulary, a lot of big words. Let's just go ahead and put it into action here. So here's really what I want you to make sure you know how to do. And again, this relates back to what we did yesterday. Remember yesterday we talked about x and y values. We had talked about this equation here, y equals k times x. Remembering that k is, again, basically the same thing as your unit rate or the rate for 1. And in order to solve for k, you could take your y value and divide it by x. Okay, your y value and divide it by x. So what I'm looking for you to do here says suppose y varies directly with x. Write an equation relating x and y. So when you write your equation, this is the equation I want you to use. Now taking a look at A, we know that y is 12, and we don't know what k is, and we know that x is 36. So what I really want you to do here is let's solve for the k value and then plug the k value back into this equation. So remember to find your k value. So again, number 1, find your k value. So again, k is y divided by x, and looking into our information, y is 12 and x is 36. So we're going to simplify this, and we're going to simplify that to 1/3. So k is 1/3. Now all I want you to do is take your k value and plug it back into this equation. So keep the y and the x out of it. Your final answer then is going to be y equals 1/3 x. Here's what this k value does. If you come up with any x value, and we get to, today we're just going to look at given data in charts, in tables, and finding a k value. Tomorrow we're actually going to use some story problems, so this will kind of all come together. But basically, with this great equation that you just came up with, y equals 1/3 x, you can come up with any x value in any sort of story problem and use this equation to find the y value. Again, it'll make a little more sense the further we get further into this. So let's take a look at B. Again, number 1, find your k value. Remembering that k value is kind of that unit rate, so take your y value and divide it by your x. Here y is 35 and x is negative 14. Again, we have it kind of written here as a fraction or a ratio, so let's keep it in that format. Let's simplify. Both of these are divisible by 7, so we'll simplify this and we'll come up 5 over negative 2. Don't change it to a mixed number or anything. Keep it written as, we're talking about rates, so we need to have those two numbers. So we have 5 over negative 2, or negative 5 over 2. Remember, it doesn't matter where you put that negative sign, as long as you just have one of them. And now that you have your k value, simply rewrite your equation using y equals, but instead of k, plug in your k value multiplied by x. And that's what I'm asking you to do for this. So let's try C one more time. Find your k value. Remember, y is divided by x. Here, y is 72 over 30, both of which are divisible by 6. We end up with negative 12 to 5, or over 5. So take our, and then, note there's no common factors of 12 and 5. So we're going to rewrite our equation. Y equals negative 12 to 5 times x. Okay. Now let's look at some information in a table. 3 steps I want you to take here. Step number 1, determine if each table represents a direct variation. Okay, so number 1, remember a direct variation occurs when you have a constant of proportionality. In other words, we're going to go through our data here and divide all of our y values by our x values and see if we end up with the same rate. Okay, and if that does occur, if you do find a k value, then state it in number 2, and then number 3, just plug in your k value for the equation. So in this case, our x and our y values are labeled for us. So let's go ahead and find our k values. Again, k values are very much the same thing as a unit rate. So here we're going to do 12 divided by 15, which simplifies to 4/5. Okay. Let's see if then we have 22 over 30, and this simplifies to 11/15. Now right away, you're going to have a k value only if this amount repeats through all of the information given to you. And clearly, just on the second try, these two do not equal each other. Okay? You cannot have a direct variation. You cannot have a constant of proportionality if you don't have the same rate. Therefore, this is not a direct variation. Because there's no constant, rate of change. In other words, also, it is not the same k value. Okay? So again, looking at information, step number 1, we're going to find our k values. K values are found by doing y divided by x. If you don't have the same k values in your information, there is not a direct variation. There's not a constant rate of change. And therefore, number 2, obviously there's no k value. And if we don't have a k value, obviously we can't fill in that equation. So you're done. Let's take a look at B. Now B, this one isn't labeled x or y for you, so let's just go ahead and label these x and y. And let's go ahead and find our k values. Remember k values, y divided by x. So this would be 24 divided by 1, which simplifies to 24. This would be 48 over 2, which also 24. This is 72 divided by 3, which is also 24. Now let me just give you a word of advice. Some of you are thinking, oh, well, you got all 24 so far. This works. However, make sure that when you do these Panthers that you try all of them. They may try to sneak that last one in and it doesn't work. So make sure that even though you start to see a pattern, you check every piece of data that you are given so that you can be confident. Now here clearly, I basically found the k values, which again, very similar to unit rates, and they all do match. So does a direct variation exist? Yes. They have the same k values. Okay. And what is that k value? K is 24. That's the value that we found on all 5 pieces of data, and therefore we're going to write our equation. Remember, it's y equals k